We will now talk about the concept of present value. Let's say that 1 year from today, you will receive a cash flow of 110. The question is, what is the value of that 110 today? To solve this, you need an interest rate. Let's say the interest rate is 10%. The present value at time 0, which is now, then becomes 110 divided by 1 plus the interest rate, which is 0.1. You solve this and you will get 100. What this means is that 110 1 year from today has a present value of 100. In other words, you would be indifferent between 100 today and 110 1 year from today. The formula, as you have seen over here, is fairly straightforward. The present value at time 0 is equal to the future value at time 1, which was 110, divided by 1 plus the interest rate raised to the power of 1. What if you were to receive money at the end of 2 years? So if you are to receive 121 at the end of 2 years, then what is the present value? Then instead of writing FV1, we would write future value at the end of year 2 divided by 1 plus the interest rate raised to the power of 2. So if we are to write this in general form, then this is what we would have. And I'll just write this in a simpler form. The present value is equal to the future value at time n divided by 1 plus the interest rate raised to the power of n. Notice also the relationship between this formula and what you have seen earlier. The earlier formula, where we were talking about future value, was the following. The future value at time n was equal to the present value at time 0 into 1 plus r to the power of n. And you can simply algebraically rewrite this as present value at time 0 is equal to future value at time n divided by 1 plus r to the power of n. So that then is the formula, and the concept, as I said before, is simply that we need to determine the present value of a certain cash flow that you will receive in the future, and we then use the interest rate to discount back. Given what you have just seen, we can say that for a given discount rate, the further in the future the amount is to be received, the smaller the amount's present value. So if you are to receive $110 at the end of year 1 versus $110 at the end of year 2, where will the present value be higher? Clearly, the present value will be higher in this case, assuming, of course, that the discount rate is the same in both cases. And you can see why. In this particular case, the present value is given by 110 over 1 plus 0.1 to the power of 1, whereas in the second case, the present value is 110 divided by 1 plus 0.1 squared. In the second scenario, the denominator is larger, therefore the present value will be lower. That is the mathematical explanation. The intuitive explanation is that clearly receiving a certain amount of money sooner is better than receiving the same amount of money at a later point in time. The next point that you should also be aware of is that holding time constant, the larger the discount rate, the smaller the present value of a future amount. So let's say that you are receiving at the end of year 1 $110 and the discount rate is 10%, versus another scenario where at the end of year 1 you are again receiving 110, but here the discount rate is 20%. Clearly the present value over here is going to be higher because we are discounting at a lower rate. In this particular case, the present value will be equal to 110 divided by 1.1, whereas in the second scenario, the present value will be 110 divided by 1.2. So again, you need to be on top of this. Let's see if you can do this practice problem now. Using the formula, here is what you should do. The contract will pay 600,000 after 8 years. So that's the future value. The present value is equal to the future value divided by 1 plus r to the power of n. And if we plug in, the future value is 600,000 divided by 1 plus r. The interest rate is 5%, so we put 1 plus 0.05, which is 1.05, raised to the power of number of periods, which is 8, and that should give you the answer, which is 406,104. Using the time value of money function on the calculator, what you simply do is the following. You plug in n is equal to 8. The interest rate is equal to 5. Notice that here we put in the percentage as opposed to in the formula where we use the decimal. And then the PV is what we are going to compute. The payment in this particular case is equal to 0, and the future value you plug in as 600,000. And when you do this on the calculator, you should get the same answer. Let's try this problem now. For a problem like this, it is useful to first draw the timeline. The security will pay $1 million in 12 years. So if this is time 0, this is time 12, this is where we are getting $1 million. College will begin 3 years from now. So that's at the end of 3 years. Notice that 3 years from now means end of 3 years. College will begin in 12 years. That means at the end of year 12. On the timeline, wherever you see the number, that number represents the end of that year. This is end of year 3. So what is the present value of 1 million at this point in time? We need to discount this back. How many periods? Between the end of year 3 and the end of year 12, we have 9 years. So this needs to be discounted back 9 years. And again, you can do this on the calculator, or you can do this using the formula. The present value at the end of year 3 over here is equal to 1 million divided by 1.075 to the power of 9, and the answer that should give you is 521,583. On the calculator, you simply plug in n is equal to 9, the interest rate is equal to 7.5, the PV is what you are going to compute, payment 0, and FV is equal to 1 million. Next question. So Orlando is a manager at an Australian pension fund. 5 years from today, he wants a lump sum amount of 40,000. Given that the current interest rate is 4% a year but compounded monthly, how much should he invest today? This is similar to what we have seen before, but the compounding now is monthly. So if he is going to receive, or he wants to receive 40,000, this is 5 years from today, but we are doing monthly compounding. So in terms of number of periods, we have at this point 5 into 12, which is 60. Between time 0 and end of year 5, we have 60 periods, and the interest rate for each period is going to be 4% divided by 12. So in the calculator, we plug in 4 over 12 as the interest rate. The number of periods is equal to 60, which is what we've calculated here. The present value is what we need to find out. The payment is equal to 0. The future value is 40,000. You plug in the numbers, compute the present value, and you should get 32,760.
All right, now let's look at non-annual compounding. And as before, we will understand this through an example. You want to know how much to deposit today to receive a lump sum payment of 100,000 after 5 years. This amount will be invested in a 5-year certificate of deposit that offers a stated annual interest rate of 10%. So this is a stated annual interest rate, but it is compounded quarterly. How much should you invest today? Before we start solving this, let's make sure we understand what's being asked. We have a 5-year time period. We want 100,000 after 5 years, and we need to calculate the present value today. We are given the interest rate, which is 10%, but we are told that this is the stated annual interest rate and it is compounded quarterly. And what that basically means is that while we have 5 years, but we need to think about 4 quarters per year. If there are 4 quarters per year, that means that the number of periods is 4 per year times 5 years, which is 20 periods. So n is really 20 and each period is a quarter. So if I say this is one period, this actually means 1 quarter. And essentially, what we need to do then is calculate the interest rate per quarter or per period, and that is going to be the stated annual rate divided by the number of periods per year, which in our example is 4, and this basically becomes 2.5. So the actual interest rate that we need to write down, which is on a per period basis, is 2.5%. Now this becomes like any problem that we've solved before, and let's just do the calculation. The present value is equal to the future value, which is 100,000, divided by 1 plus the interest rate, which is 2.5% or 0.025, raised to the power of the number of periods, which is 20. And when we do this calculation, we should get the present value, which is 61,027. Now, I'll also connect this with the formula, which is given in the curriculum, and you will also see the formula in our notes. So here is the formula. The present value of a single cash flow is equal to the future value at time n. Now, this is the 100,000 number. So FVN is 100,000 because we want 100,000 at the end of n years, and n is 5. And then to come up with the present value, we divide by 1 plus an interest rate to the power of the number of periods. RS is the stated annual interest rate, which is 10% in our example. We divide that by M. M is the number of periods in the year, which is 4 because we are doing quarterly compounding. And this will essentially give us what we have over here, 1 plus 0.025. 10% over 4 is 2.5% or 0.025. And then this is raised to the power of the number of periods. And I also did that calculation earlier. M is 4 and N is 5 years. So 4 times 5 is 20. And that's what we show here. So this is the formula, and you should also understand how to use the formula. If you get a question like this on the exam, you should use your calculator. And with the calculator, obviously, you need to know how to plug in the numbers, and you need to know the numbers. So N here is 20. The interest rate is 2.5%. So that's what you plug in. The future value is 100,000. And then you also put in a payment equal to 0. Payment 0 means that there is no payment happening in between. This is just a single cash flow for which we are calculating the present value. So payment needs to be explicitly set to 0. And then you compute the present value and you should get this answer. I'm sure you've done this already, but if you haven't, then make sure you watch my calculator videos to understand how to use the calculator. Moving now to the present value of a series of cash flows. And when we talk about a series of cash flows, either we can have a series of equal cash flows or a series of unequal cash flows. When we have equal cash flows, then this cash flow stream is called an annuity. And let's make sure we understand what's meant by equal. Equal means that the cash flow is happening at equal points in time. In other words, let's say the cash flow is happening every month. So we have a certain cash flow every month. And also equal means that the amount is the same. So for example, if I say that you will get 100 every month for 4 months, then this is an equal cash flow. It's also called an annuity. If this cash flow starts at the end of period 1, then it's called an ordinary annuity. And if this cash flow starts right now at time 0, then it's called an annuity due. Over the next few slides, we will look at different methods for calculating the present value of a series of equal cash flows. Now, there is one more example of a series where we have equal cash flows, and that's called a perpetuity. A perpetuity is where these cash flows go on forever. So if I say to you that here is an instrument, if you buy this instrument, you will get $100 every month forever, then that is a perpetuity. And the name is pretty self-explanatory. Perpetuity means that essentially you will be getting this payment perpetually or forever. With respect to unequal cash flows, the concept here is fairly straightforward. If you have a situation where you will get a certain amount of money, let's say 100 at the end of period 1, at the end of period 2 you get 200 and so on, this clearly is unequal. Also, if you have a situation where at the end of period 1 you get 100, then period 2 there is nothing, then period 3 there is 100, period 4 there is 100, while you are always getting 100, but since this is not happening at equal time intervals, this would not be considered an annuity. This would be considered unequal cash flows. And here again, we will look at how to calculate the present value of unequal cash flows in the next few slides.
First, let's calculate the present value of an ordinary annuity. And as you've seen before, an ordinary annuity means that the first cash flow will occur at the end of the current period. So if you are here at time 0, an ordinary annuity means that the first cash flow, which in this case is 10, will occur at the end of year 1 or end of period 1. When we say n is equal to 5, that means that this payment will happen 5 times, and the interest rate that is given is 5%. The brute force way of calculating the present value is to simply take each cash flow and compute the present value. So if you simply take the present value of every cash flow and then add up all these numbers, what you should end up with is 43.29. And I have just done this for illustration to demonstrate what actually is going on. Clearly on the exam, if you do something like this, it will take too long. So this is not the recommended way of solving a problem like this. Another strategy you can use is to apply this formula. What we do here is again recognize that we have the same annuity, 10, 10, 10, 10 and 10. The present value at time 0 is given by this formula, which I will rewrite for you. So A is the annuity amount, which is 10, multiplied by 1 minus 1 over 1 plus r to the power of n. R is the interest rate in decimal. n is the number of periods, which in this case is 5, and then we take this entire amount and divide by the interest rate. If we plug in the numbers, A is 10, the interest rate that we plug in is going to be 0.05, n will be 5, and here also 0.05. And when you solve this, what you will get is the same answer that we had from the previous slide, which is 43.29. This expression in brackets is called the present value factor for the annuity. While this formula is good to know, but it is not necessary that you memorize this formula, because in the real world, problems such as this will be solved on a computer. In your exam, a problem such as this should be solved using the calculator. So let us make sure we understand how to solve this using a calculator. It is the same annuity, and on the calculator you use the time value of money function. So you plug in n is equal to 5, the interest rate is also 5, the present value is what you'll be computing, the payment is 10, and the future value is 0. When you plug in these numbers, the answer that you should get is 43.29. So in essence, we have gone over 3 different methods for coming up with the present value at time 0 for this annuity. The fastest, most efficient method is the calculator method, and that is the one you need to use on the exam. Moving now to the annuity due. With the annuity due, the first payment is received at the start of the first period. So if we say that we have an annuity due with A equal to 10, that means that the first payment is received at time 0. And then if we are told that n is 5, that means that this payment will be received 5 times. So the final payment is end of year 4, which is the same as the start of year 5. Again, to calculate the present value, the brute force method would be to take the present value of each cash flow. The present value of 10 is 10. You can then compute the present value of all subsequent cash flows and then add up these numbers to come up with the present value of the annuity due. Notice that with the annuity due, you are receiving money faster, which means that the present value of annuity due is going to be greater than the present value of an ordinary annuity. You can also come up with the present value of an annuity due using the formula. And take a look at this formula. I will rewrite it for you. A multiplied by 1 minus 1 over 1 plus r to the power of n, and this entire amount divided by the interest rate, and then we multiply this expression by 1 plus r. This expression is the same as what you saw earlier. In other words, this is the present value for an ordinary annuity. And see what's going on here. If you have payments at the start of every period, then the ordinary annuity formula gives you the present value 1 period before the first payment. So if there is any such thing as a minus 1, the ordinary annuity formula is simply giving you the number over here. And then that number that we arrive at using the ordinary annuity formula needs to be taken forward 1 period. That is why we multiply by 1 plus r. So again, you can simply plug in the numbers. A is 10, r is 0.05, n is 5, and again 0.05 and 0.05. You can plug in these numbers and get the answer for the present value of the annuity. And the answer that you should get is 45.46.
Let's now calculate the present value of an annuity using the calculator.
The point is that you first have to put the calculator into begin mode. The default for the calculator is that it is in end mode. In other words, when you simply plug in numbers, the calculator assumes that the cash flows are happening at the end of each period. When you press these buttons on the calculator, second begin, which is right here, and then second set, that puts the calculator into begin mode. So notice when you do this on the calculator, it will then say begin here on your screen. This means that the calculator will now assume that any cash flow that you enter is really happening at the start of each period. Second quit, to simply put the calculator back into standard mode. You clear the time value of money, and then 5n, so we are saying that we have 5 periods. The interest rate is 5, the payment is 10, future value is 0, and then you compute the present value. And what you should get here is 45.46, which is the same answer that you should have gotten on the previous calculation. And notice also that 45.46 is equal to the present value from the ordinary annuity, which is 43.29 multiplied by 1.05. Once you are done with the calculation and you have come up with the present value, then you need to change your calculator back into end mode, because most questions will be solved assuming payments are at the end of the period. So you need to put the calculator back in end mode. If you do not do this, then all future calculations will be performed in begin mode. And then again, second quit to get back into standard calculator mode. Next, let's look at the present value of a series of unequal cash flows. All we do here is find the present value of each individual cash flow and then sum up the numbers. So if you have $100 here, 200 and 300, and the discount rate is 10%, you find the present value of 100, present value of the second number, present value of the third number, and then all these items are added up to come up with the present value. Let's do this example. The first thing you should do here is create your timeline. So you have 5 time periods and 5 payments happening at the end of each of those periods. The payments are 50, 100, 150, 200 and 250. You take each payment and discount back at 9% and then add up all these numbers. The answer that you should get is 550. This is a long-winded way of solving the problem. In the next reading, I will show you how to use the calculator to solve this problem. Moving now to the present value of a perpetuity. And if you recall, a perpetuity is a never-ending series of equal cash flows. So let's say we have a really simple perpetuity where you receive $10 at the end of every year forever. And let's say that the discount rate is equal to 0.05 or 5%. The present value of this cash flow is simply given by the amount, which is 10, divided by the discount rate, which is 0.05. So the answer here is 10 over 0.05, which is 200. Keep in mind that the present value of 200 is one period before the first cash flow. The first cash flow is happening at time period 1. The present value is one period before the first cash flow. Many people incorrectly show the present value of 200 at the same time as the first cash flow, but again, that is incorrect. you need to show the present value, or the present value is one period before the first cash flow. So let's look at another example. If you invest $100 and get 5% forever, what is the cash flow? So if at time t equal to 0 you invest $100 and get 5%, then every year you will get $5. So notice then, $5 every year forever, where the first payment is received at the end of year 1, is the same as having $100 today, assuming a 5% rate. So look at the calculation here. The rate of 5%, 0.05, is equal to the $5 which you get at the end of every year divided by the investment. So if we write this as symbols, the rate is equal to the amount, 5 is the amount, divided by the investment amount, which is the present value. So this expression has simply been rewritten to come up with this. Using very basic algebra, you can then see that the present value is equal to A over R. So that is where this expression comes from. Present values indexed at times other than t equal 0. An annuity or perpetuity beginning sometime in the future can be expressed in present value terms one period prior to the first payment. Let us look at a simple example here. Let's say that I offer you a cash flow which starts at the end of year 5, and this goes on forever. So I'll give you $10 at the end of year 5, end of year 6, and so on forever. So this is a perpetuity which is starting at the end of year 5. The question is, when we use the annuity formula, or actually in this case the perpetuity formula, the present value is equal to the amount A, or the payment, which is 10, divided by the discount rate. Let's say that our discount rate now is 0.1 or 10%. So the present value is 10 over 0.1, which is 100. This present value of 100 is one period before the first cash flow. So what we can say is, for this entire perpetuity, which starts at the end of year 5, the present value will be one period earlier. So the present value will be here, and that present value is equal to 100. In other words, present value at the end of year 4 is equal to 10 over 0.1, where the first payment of 10 is happening at the end of year 5. So what then is the present value at time 0? That will simply be the discounted value of 100. So present value at time 0 will be equal to 100 discounted back to time 0, which would be 100 divided by 1.1 to the power of 4. Power of 4 because this 100 is being taken back 4 periods. Let us see if you can solve this problem now. The first payment will be received at t equal to 4. That is right here. And then this payment will be received at the end of every year forever. So this is a perpetuity. The present value of the perpetuity given a discount rate of 10% would be 100 divided by 0.1, which is 1000. So this present value is one period before. So the present value at time 3 is equal to 1000. This value of 1000 is equivalent to all these cash flows which start at the end of year 4. We want to know what is the present value at time 0. So that is simply going to be 1000 discounted back 3 periods. So that would be 1000 divided by 1.1 to the power of 3. If you do the calculation, you should get 751.31. This can also be done using the calculator, where the future value is equal to 1000, the payment is 0, the interest rate is 10, and you compute the present value.